Topic is uniform circular motion. We'll see. Okay. Um, so far we saw how the motion of a particle in a plane, right? You got a clear idea about how the particle is moved in a plane, right? Plane means, what is plane? 2D, two-dimensional frame of reference. You are taking, your observation should be in the 2D point of view. It's in a plane. Okay. So right now we are going to understand the particle's motion. You are so far recorded like a linear motion. The particle is moving in a translatory motion or in a linear motion. Right now we are going to see if the particle is moving in a curvical motion, curvilinear motion, or it may start and end at the same point. Then what about this one? Circular motion. Is it visible properly? Is it visible? Going on? Okay. Is it visible? Okay. Then what it says? What is uniform circular motion? Here it says, what is uniform circular motion? What here it says? The circular path at constant speed. Okay. If the particle is moving in a circular path at constant speed. What is the meaning of constant speed? It is not constant velocity we are saying. What is that? Constant speed. What is the meaning of constant speed? Same elsewhere. Elsewhere the particle is moving. It should move with the same speed, not with the velocity. What is meant by velocity? What is the major difference between velocity and speed? What is the major difference between velocity and speed? Scalar and vector, right? What is scalar? What is vector? If a particle is moving like this in a circular motion, okay, the starting point and the end point will be the same here. Okay, so you are talking about the distance traveled by the particle, okay, or an object. The distance traveled by an object from here, 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 here. Like this, if you record, the starting point and the ending point will be the same. Okay, so if you see this, what is the total distance traveled by this particle or the object? Yeah, very good. Circumference of a circle, that is 2 pi r. That is the total distance. Okay, what it might be the displacement here? Why it is 0? Very good. So it ends at the same point. If the particle is moving from, you have to understand the circular motion like this. Okay, if a particle is moving from this point, okay, this is the center, from this point to this point. Say for example, it is pi by 2. Aryan, I've taught you also the size. Okay, be there, just listen. Okay, what is this? 90 degree.
Brightness.
You want?
Yeah, brightness is, reduce the brightness.
Is it okay? Is it okay?
It's coming back. I think you have to.
Is it okay?
Yeah, okay. Just don't go in the center, or else the screen will be blurry and one end will be too.
Yeah, that is the natural process from the Samsung. Okay.
Okay.
So you don't worry about that. Okay. So what it says, if the particle is moving from this point to this point, from A to B, for example, it moves with an angle 90 degree. So what is the total distance traveled by a particle when it completes a circle? So that is 2 pi r. Aryan, listen.
Yes.
That is 2 pi r. Okay. Suppose if the particle moves from here to here, it covers the angular distance of 90 degree. So what is this length of an arc right now? Huh? 2 pi r by 4, or it will be, yeah, so pi by 2 r. Is it clear for you? So it is the 1/4 of a whole circle. Can you able to understand? So it is what is 2 pi? 2 pi is 360 degree. If the particle completes one complete revolution, then 490s it has to cover. Got it? Okay. Then 490, 4 times 90 is 360 degree. So 180 degree is equivalent to pi value. Okay, pi radian. If you convert degrees into radian, okay, degrees you can consider at the center. The radian can be represented as a length. Okay. So 90 degrees, the arc length will be in radians. Got it? In the first lesson, it will be given to you. First lesson, you have studied about the solid angle, okay, the arc length and everything. Okay, I'll teach you that again, no problem. So what it is given here, 90 degree means what happened, this pi is equal to pi by 2, right? Pi, what is the pi value? 180 degree. What is 90 degree now? Pi by 2, right? So pi by 2 times r will be, this is the radius. So r will be the, pi by 2 times r will be the distance traveled by the particle. Okay, so this distance is nothing but what type of distance it is. Actually, we talk about if the particle is moving in this particular distance, we consider only the velocity. The velocity of the particle here, not a velocity, speed. If you consider the speed of a particle here, and then here, if everywhere elsewhere, it should be same. If it is not same, it should not be traveled in a circular motion. It may deviate, right? The velocity varies, it may deviate. It won't be coming to the circular motion. Okay, so each and every particle moves in a uniform speed. It covers the circular motion, one complete circle. Suppose if the particle moves from here to here, so 180 degree, right? The total distance will be pi r. What is the displacement here? D, 2r. Very good. So what is the distance and displacement? Distance is pi r, displacement is, Aryan, do listen. What is the displacement? 2r. So I've taught you on that day this r plus r, right? Shortest distance traveled by the particle. See, this is one point, A, B and C, right? If the particle is moving from A to C, so one bicycle problem I taught you. Go and take your book and come. Okay, see that. Okay, so revise it. What it says, from A to C if the particle is moving. Okay, what is the total distance covered particle? Where is the path of a particle? Here only. Okay, what is the actual shortest distance the particle can go from A to C directly like this also? Got it? Get my point. So, like this if you talk about, then that will be the displacement. The shortest distance maximum, it should be in a straight line motion, the shortest distance, okay? So always the uniform circular motion talks about the uniform speed, not the velocity. We are taking only distance, not the displacement. Is it clear for you this one? Okay. So then, if there is a, but this is very important point. Suppose an object is moving with uniform speed in a circle of radius r, okay? Since the velocity of the object is changing continuously in direction. What is the meaning? I've told you we are talking about the distance as well as the speed. Here it says, what it says, since the velocity of the object is changing continuously in direction, the object undergoes acceleration. So where the velocity comes? Here. You are considering a circular motion of an object. The object is moving, okay, like this. If you say it is moving with some velocity, so this point is A point, BA velocity. B point VB velocity, C point VC velocity, D, then VD, E, VC. Like this, sorry, VE. Like this you can take. So what I am trying to say, here you are considering each and every velocity tangentially. The particle's velocity will be act on a point tangentially. Okay. And then if you see this velocity, the velocity direction changes. So the direction is involved. Suppose if you say it is a speed of a particle, its direction is changing. Got it? So direction is involved in a movement of a particle, path of a particle. So that we can say the velocity is there. But the velocities keep on changing in its direction, not in the magnitude here. Constant speed, it talks about only magnitude. Okay, but there is a velocity due to the change in the direction, then only the circular motion will be. If the direction is not changing, it will be in a linear motion. Okay, since it is in circular motion, the direction changes continuously and then thereby it experiences acceleration also. Can you able to understand? There are two types of acceleration you are going to learn about, tangential acceleration as well as the centripetal acceleration. Okay, we'll see that. Towards the center also there must be an acceleration, and then along this tangential motion also there must be an acceleration. Acceleration means rate of change of velocity. Here the velocity is changing only in direction, not in the magnitude. Okay, so keep this in your mind. See this, what this picture conveys, all of you. Velocity and acceleration of an object in an uniform circular motion, right? So here, where is the velocity? They have taken the time interval delta t decreases from A to C. Okay, this is the picture A, B and C. What it says, the time interval delta t decreases. Okay, the acceleration is directed at each point of the path towards the center of the circle. See here, so they have taken the point's position. So I've taught you, right, the complete circle. Okay, there are 2 points of a path of an object. Okay, so initially the object is here and then it moves here. I told you, right, VA, VB like velocity. So the velocity is varying, velocity is here. The velocity varying means not in the magnitude, only in the direction. Okay, so here what it says, this radius. Okay, this is the center, but here it says this might be R, this might be R prime, and this is some angle. I mean, that angle might be delta theta we are taking. The total angle is theta. In your book it is given, instead of 2 pi, it is theta. Instead of some angle, they have taken some delta theta, some small change in theta. So this will be the delta R. What is delta R? R prime minus R. This you could have already done in the triangle law of addition. Do you remember that? So this is delta R. Okay, like this, you can take this velocity. Okay, you know this is the superimposable objects. That means superposition. If the vectors are free, then you can superimpose both the vectors and you do apply any type of addition, that is triangle law of addition or parallelogram law of addition, in order to find the resultant, the total. Okay, see what is this? Here you have taken the velocity v. So at this point you are merging with this point. Okay, you are just merging these 2 points. Then how the velocity will be like this? Can you able to understand? This velocity v is in this direction, this velocity v prime is in this direction. Okay, then what is the resultant? The resultant will be delta v. It is in the opposite direction, right? The head representing. So it is v prime minus v you can take. So delta v. Is it clear? Clear or not? Because otherwise you need to use which theorem? Parallel. What law of addition you have used here? Triangle law of addition. Okay. See, these two are actually joined in tails. Okay, you need to exchange this. That means you need to change its direction. This V's direction should be changed, negative V. Got it? Then only the third side will be the resultant. V prime minus V. Is it clear for you? That's why we have represented here. The third side will be the resultant of the particular given vectors. Okay. So this represents the triangle of addition. Here we are using triangle of addition since these vectors are free vectors. We can able to merge it further. If the vectors are fixed vectors, we can't do. We can do only with the help of parallelogram law of vectors. You know the parallelogram law of vectors addition will be along the diagonal of a particular vectors. Okay, that means it forms the parallelogram, right? That also you know how to find the magnitude, you know how to find the direction, means of that. Okay, so if you want to know, it will be in the previous recording, you can go through it. Okay, then what it given, is it clear for you? Then see the next, what is given in the next, what is given in the next mark? Delta R reduces, right? Delta theta is reduces. So here what it says, the acceleration acting towards the center, it represents. So this type of acceleration is actually centripetal acceleration, towards the center it is. I'll explain you that. Okay, so here also it may experience acceleration due to the various speed, various velocity. So that type of acceleration is tangential acceleration. Okay, so let me come to that point. What is given in your book, we'll see now. So here, what we have discussed, that is given here. And then what is an acceleration? Acceleration is delta V by delta T, rate of change of velocity. That is an acceleration, right? You know, what is an instantaneous acceleration? If delta T tends to 0, that is an instantaneous acceleration. That everything I've explained you already, right? If you put limit delta T tends to 0 at the short time, okay, no one can predict any velocity within the particular short time, right? It might be deviating exactly plus or minus 0.000 something. Okay, so delta T approaching to 0, it is not exactly equal to 0. So if it is exactly equal to 0, it doesn't have any meaning. It will be unknown. So limit delta T tends to 0, delta V by delta T. Okay, so what it says, this is an instantaneous velocity. You can find instantaneous acceleration also. So since it is directed towards the center, the average acceleration becomes the instantaneous acceleration. So that's what's shown in this picture. Here and all, you have taken an average velocity, and then finally here it says the inverse acceleration, right? So what is the meaning of that? Here the velocity is, the acceleration is instantaneous acceleration. Got it? So all the instantaneous acceleration is pointing at the center. Okay, is it clear? It becomes, average acceleration becomes the instantaneous acceleration. Okay, so instantaneous acceleration, you know, okay, this is the magnitude of A. Then angle between these two will be delta theta, you know. Now here it comes to the point, what it says. Therefore, the triangle CPP prime formed by the position vectors and the triangle GHI formed by the velocity vectors are similar vectors. They have taken like that. You know, right, from that picture, this P prime and center. This is delta R prime, like that they have taken. Similarly, V prime, V and delta V. So these triangle they have taken as, what is that? GHI, like that they have taken. They are considering these two are similar vectors. Similar vectors means what it will be? Their sides will be proportional. Okay, their corresponding sides or their corresponding angles will be proportional, right? This and all you have learned from your 8th standard onwards, right? So, what are all the sides here? See, if it is delta V, this delta V, and then you are considering where delta V and delta R you can consider. So, see, for example, the ratio of the base length to side length for one of the triangle is equal to the other triangle. Like that they have taken. Okay, delta V by V. Okay, and then delta R by R they have taken here. 1 second. See the picture. This is taken as the picture. Okay, so capital R is given as the radius. Okay, radius of the circle. So delta V by V and delta R by R. Okay, so that means they have taken the change in velocity by original velocity, like that. The change in length, I mean the radial length by original length. So that it is not given here. Initially, it says the particle is moving in a curvilinear motion. Initially, we don't know whether it is completed the circular motion. Okay, ma, that's why they have represented R prime. They didn't know whether it is radius or not. Finally, they concluded if it is radius, then it follows the complete circle. Got it? So, here, then you can rewrite like this. Can you? You can able to rewrite this. Then what is the acceleration? Acceleration is instantaneous acceleration. So here in the place of delta V, you are going to substitute this. Okay. Then what happened? What is delta R by delta T? So this V is constant speed, right? R is also constant radius. So we can take V and R outside. Then what is delta R by delta T? It is a kind of, this delta R is a kind of the distance or displacement, we can say, right? Rate of change of displacement also we can take it. What is rate of change of displacement? It's also a velocity, right? So you can consider this delta R by delta T is simply equal to V. Can we write like this? Is it clear for you? Okay, this acceleration, first instantaneous acceleration you found from this. Now we are pointing the centripetal acceleration. So all types of force you have learned, right? If the particle is moving, if you tie a stone on a thread and then you are just making it to rotate or you are slinging that, then what will happen? It forms a circular motion. Then the force is acting. Or else you can see if you ride a bicycle, okay, so while it is running, you can have a stable equilibrium. Can you able to stand a cycle without stand? It won't be, right? Why? What is the reason? There are two types of forces, circular forces, centripetal and centrifugal forces. Okay, when you pedal, okay, when you are pedaling, that is the force given to that particular wheel, right? That force is acting towards the center. Okay, that should be balanced by the outer force. So what we call that as a friction between the surface, road surface. Okay, that is also known as centrifugal force, which is outwards. These two should be balanced. Otherwise, the cycle won't be moving or it won't be stable. Okay, so while the cycle is under circular motion, the cycle wheel is under circular motion, it is moving steadily. Got it or not? Okay, due to the balance of these two forces. What are the forces? Centripetal is towards the center and centrifugal is outside, outside the circle. So these two are balancing. See, for example, if you are pulled by any two persons equally, both of your hands, okay, so two of your friends are pulling you, both of your hands equally, they are giving equal force upon your you, okay? Then you can able to stand firm, right? You didn't even experience their forces. They are pulling at one side, the same force, the other side also you are experiencing. So you won't be moving, right or not? You are facing the stable, what I can say, the particle is constantly moving like that. Okay, so here also in a circular motion, the particle is moving in a constant speed, so that towards the center there is an acceleration. So that acceleration is known as centripetal acceleration. What is centripetal acceleration? That also we are going to derive it. You know about normal acceleration right now. This is normal acceleration. Okay, so tangential acceleration is rate of change of velocity. Then what is this? Averager or instantaneous? Which one? Instantaneous. So this is, we can usually name this tangential acceleration as average acceleration too. Okay, this average acceleration is perpendicular to delta r, it says. This is also a very important point. You should consider this average acceleration, or we can say this tangential acceleration. Tangential means that movement we are talking about, okay? It is perpendicular to delta r. Okay, it is exactly perpendicular to this delta r. Then what it says after this, we are talking about the instantaneous acceleration. So for an instantaneous acceleration from this circular uniform circular motion, from that case we have given an idea. So what is this? It talks about v by r into limit delta t tends to 0, delta r by delta t, that is equal to simply v. So we can usually call a is equal to v square by r. Can we write like this? This limit delta t tends to 0, delta r by delta t, rate of change of displacement is v, right? Instead of all these things, we can replace v. So v by r is already there. So v into v square by r. So this is called the centripetal acceleration. I'll explain it. So this is centripetal acceleration, v square by r. Okay, it is directed towards the center. Okay, what is the centripetal force? We can say mass into acceleration. Force is mass into acceleration. If you want to write the centripetal force, then what is this? mv square by r. Okay, so it is always directed towards the center. Okay, you can go through this all. Then, if you talk about the angular velocity, you are taking the angular displacement. Okay, so the two position of a particle, it is moving. Okay, this is r prime, and then you know this as delta theta, right? So this will give you, this is the angular displacement. Okay, it is an angular displacement. What is this angular rate of change of angular displacement? Is the angular velocity. It is characterized by a letter omega. Okay, what is this v stands for? You know, it is the linear velocity. Linear velocity is rate of change of normally displacement, linear displacement. Here it is angular displacement. Okay, so there is a relationship between the angular displacement and the linear displacement. So that is what given here. What is this? Delta S is equal to, what is delta S here? If you talk about, if the particle completes circular motion, then this r prime will be r only, right? R is equal to r prime is equal to r. That is the radius of the circle, right? Then what it will be? So this also r, this also r. Okay, so what is this delta S? It is the length of an arc, right? Is it clear for you? So what is the length of an arc? You have studied in your first lesson. And then you have learned so many theorems also. Central angle theorem. What is central angle theorem? Theta by 360 into 1 into 2 pi r. So if you want to find the length of an arc of a circle, Okay, what is the formula? Theta by 360 degree into 2 pi r. So this part is the length of an arc. Okay, this part is the length of an arc. It is denoted by a letter, delta is here. And then this part is the central angle, delta theta out of 360. Okay, so delta theta out of 360 is 2 pi into 2 pi capital R. Okay, ma? So 2 pi gets cancelled. So delta theta into R. Right or not? So delta S is equal to length of an arc. So make a note of this, all of you. It won't be given in your book. So draw like this and then do right. If the particle completes a circular motion, then the resultant will be like this. So delta S is equal to R into delta theta. So that is what given here. Take a note, make it fast. Finished? Finished, Amma? Aryan, you can also do that bicycle problem.
I already finished.
Yeah. Is it clear for you? You must understand the circular motion clearly. So you've been taught in class 11 also. Got over? Balaji? So from this we can understand what is this? So delta S is equal to R into delta theta. So out of it, so we can divide both the side by delta t. Got it? So this is velocity. Okay, rate of change of displacement is normal velocity. Okay, linear velocity. This is linear velocity. Linear velocity. Okay. And then this delta theta by delta t will be omega, that is angular velocity. Got it? So this is the famous relation between the linear velocity and the angular velocity. It is very, very important. Okay. Take a note of this also. Okay. So it's a famous relationship between the linear velocity and the angular velocity. And then you can go through this problem. It is very simple problem only. So I'll explain you right now. Make it fast. Copy it. Okay. Then here it comes. You know what is this AC? A suffix C. What is this? Huh? What is this? Tell me, Kavya. Centripetal acceleration. Right. So centripetal acceleration is V square by R. So you can substitute for, this is linear velocity. You can substitute for the angular velocity. What is angular velocity? R omega. Can we substitute? So V square will be R square omega square. Okay, then one R gets cancelled, then it will be omega square R. So now, so first of all, this is the acceleration, centripetal acceleration in terms of linear velocity. This is the centripetal acceleration in terms of angular velocity. Clear? Okay. So suppose if you take the number, if a particle is moving circularly like this, the span and all, suppose for example, if you are considering which one, something it is moving, rotation, even a fan also, right? Its span means what is the span? Yeah, it's moving on. It's moving on and on and on. Now it is rotating. Its RPM will be rotation per minute will be like this. It is given, right, in a fan and all. So you'll be seeing one rotation completed, two rotation completed, three rotation completed. Each and every rotation is taken as a frequency. Okay, the number of rotation per second. Per second, the blades of a fan is rotating, right? So per second, how many number of rotations are completed? So that is taken as a frequency. Okay, so what is the frequency? Frequency is characterized in terms of T. What is T? Time period. So I've told you the number of rotations or the number of oscillations or the number of vibrations we can say, okay, or the number of acceleration also we can say per second. So time is involved. Per second means 1 by time period. Okay, so 1 by time period is frequency. Frequency in your book, sometimes it is given as F, sometimes it is given as N, sometimes it is given as nu. So this is the frequency representing letter. So nu. So nu is equal to 1 by T. Okay, what is this? Yes, you know, the total length, they have taken the circumference. Total length of a path of a particle. So that is 2 pi r. And then what is the velocity? The total distance covered by the particle by time period. Okay, so 1 by T is taken as nu. Can we write like this? Don't confuse with this velocity letter. While writing, listen all of you, while writing you can write the velocity as big V and then this is like a curl V like this. Okay, it is the nu. You should show the difference between the velocity and the frequency. Is it clear for you? So velocity can be, you know, the distance, the speed is equal to distance by time. That is the formula they have used here. Okay, speed is equal to distance by time. Okay, so what is the distance traveled by the particle? Whole distance is 2 pi r. The time period is capital T. Here it is given 1 by T is nu. Okay, in terms of frequency, if you want to write, then what is the frequency? 2 pi into nu will be the omega, the angular velocity. Okay, so what is this velocity? Because you can compare this, right? So what is V you have calculated from it? What is the V you have calculated? Very good. So here it says V is equal to 2 pi nu into R. You know V is equal to R omega, right? So in the place of omega, it is 2 pi nu. So clear for you? Then what is the acceleration due to the centripetal acceleration due to the angular velocity? If you consider angular velocity, what is the centripetal acceleration? Omega square R. So 2 pi nu the whole square into R. Is it clear for you? AC in terms of this frequency. So keep in your mind. So using all these derivations, you will be asked so many questions. Okay. So you can able to write the centripetal acceleration in terms of simple displacement. And then you can write the centripetal acceleration as an instantaneous acceleration. You know what is the reason for that? While in a centripetal acceleration, all the path of a particle you are considering, if it completes one circle rotation, then it is moving with a constant speed. The distance will be r at all the points, right? It won't be changing. So that the acceleration acts towards the center. So that is the centripetal acceleration. Centripetal acceleration, you know, v square by r. That v is the linear velocity you have taken. If the particle is moving along the circular path, that velocity is linear velocity. But if you talk about the angular displacement, delta theta, so angular velocity is taken into consideration. So what is the major relation between the linear velocity and the angular velocity? V is equal to R omega. That is the relation between linear velocity and angular velocity. What is the relation between the acceleration to the angular velocity? Omega square r, right? Acceleration means centripetal acceleration. That is equal to omega square r, right? In terms of frequency also we can write. What is meant by frequency? Let me know. Very good. The number of rotations per second. Okay. So the particle is moving circularly. So how many number of complete rotations are there? So based on the time period. So that is the frequency, right? So 1 by t is new. It is replaced by the frequency. In terms of frequency also you can write. What is the acceleration here? Centripetal acceleration. 4 pi square nu square into r. Is it clear for you? This is all about, you have learned so many formula here. Okay, you have to understand what is the problem and then you do solve. We'll solve so many problems from these questions. Right now you can learn all these things. Okay, I'll teach you this example. Then I'll give you so many extra problems for this. Okay, then what is the question? What is the question here? An insect trapped in a circular groove of radius 12 centimeter moves along the groove steadily and completes 7 revolutions in 100 seconds. That's what given here, right? So 7 revolutions in 100 seconds. What is the angular speed? It is asked. Linear speed also asked. Then acceleration vector, a constant vector. It is asked. Is the acceleration vector a constant vector or varying vector? It is asked. Then what is its magnitude? You know, it is completing 7 revolutions in 100 seconds. So obviously it is an uniform circular motion. R is equal to 12 centimeter. It is given, right? So what is omega now? 2 pi by t, right? What is omega? Angular velocity. Angular velocity is total angular displacement. What is angular displacement, ma? So here new formula is arrived. Got it? So what is angular velocity? Angular velocity is equal to angular displacement. Angular displacement is 2 pi, right? Delta theta, what is the whole theta will be? 2 pi, okay? So 360 degree by time taken. Okay, then, so 2 pi, what is this time taken here? What it says? It completes 7 revolutions in 100 seconds. So into 7, right? 1 time is 2 pi. So 7 times it is. So 2 pi into 7 by 100. So how much radians? It is the unit for omega. That is also very important. What is the unit of omega? Delta theta by delta t. Theta is now converted into radians, not in degree we are taking. So radians per second. So this is the velocity unit. I mean angular velocity unit. What is the linear velocity unit? Meter per second. That you know, right? So it is radian per second. So linear speed will be meter per second or centimeter per second, whatever it might be here. You know, from this we can calculate linear velocity. Omega into r, right? So it is in centimeter, 12 centimeters or centimeter per second. So what is the direction of the velocity? V is along the tangent to the circle, right? That we know. Right now only I taught you. The velocity will be tangent to the circle. Then the acceleration is directed towards the center of the circle. Right? So since this direction changes continuously, acceleration here is not a constant vector. Because direction of the velocity is continuously changing. So acceleration will not be the constant one. Okay, that is the answer for this second option. Then the magnitude of acceleration it is asked. You know, right? The formula omega square into r. You can apply in it, find the numerical value. Is it clear for you? It's an easy problem. It is given in your book. You won't be getting this kind of problem for your board exams or NEET or JEE or whatever it may be. Okay, you have to do lot of problems based on this. I'll solve you some extra problems for this. Okay, bye bye.